Hello everyone, you're welcome again to my YouTube channel. So in this video we are continuing um, our study on how to solve Olympiad maths problems. So this one says that which of these numbers is a perfect square. Now you remember that to be able to find whether a number is a perfect square or not, the usual approach is to make use of the concept of prime numbers and prime factors. Okay, so we will usually express the number as a product of its prime factors and then be able to know whether it is a prime is a perfect square or not. For instance, let me use let's say a number like 25 is okay. Let's not use 25. Let's use 36 for instance. 36 is a perfect square. So, and the usual approach is to express it as a product of these prime factors, which you do by starting a division with the smallest prime factor, which is 2. So here we have 18. 2 will go again. Here we'll have 9. This time 3 will go. We'll have 3. And then 3 again will have 1. So since 36 here now is equal to 2 times 2 times 3 times 3. So of course you can see that so far as you can pair each of the factors, you can put them in pairs, then that number is a perfect square. Now let's use a counter example to see what we are saying. Let's check for 24. So if we check 24, 2 can go, we will get 12. 2 can go again, we will get 6. 2 can go again, we'll have 3. And then 3 will get 1. So you can see that this is equal to 2 times 2 times 2 times 3 now. Okay, so carefully looking here, you see that these two will pair. Now this one has no pair and this one has no pair. Okay, so that is to say that 24 is not a perfect square. Okay, so now this is actually the usual approach for determining whether a number is a perfect square or not. Now, but in this case, now you can see that the numbers we are given are all large numbers. And of course, this exam, you have limited time. So it will take a lot of time to be able to, use this approach to know that or to determine which of these is a perfect square. So what are we going to do then? So, and that is why we say this will now involve some rules of number theory. And what are those rules? Now, you remember that if you want to take the square of a number, let's say 12 squared, your 12 squared is actually 12 multiplied by 12. And that means 2 is going to multiply itself for you to get that. In fact, that is going to be the first digit you're going to have. Okay, so that is to say that if I want to get the square of any number, that the square of the last digit will determine the last digit of the number I will square. Now look at what I am saying. If I multiply 12 by 12, the last digit of this square is going to be 4, because and what determines that 4? The product of the last two digits that you have there. Okay, for example, again, if I have 25 squared, this is 25 times 25, sorry, this way. Okay, so of course you see 5 will multiply 5 and that will give us 25. So you write 5 carry 2. So you see that the last digit of any square is always determined by the last digit of the number you're taking the square. So since we are taking the square of 25, so we are going to make use of 5 to determine what will be the last digit of that square. Okay, so in other words, if we want to know what the last digit of any squared number is going to be, all we need to do is to take the square of all the first digits that we have, starting from 0. If we take the square of 0, that will give us 0. The square of 1 is 1. The square of 2 is 4. The square of 3 is 9. And the square of 4 is 16. And so the last digit of this is 6. So I am only writing the last digit because it's eventually the last digit that we will now have as the last digit of any number that has 4 as its last digit. For instance, if I want to square 24 now, That's going to be 24 multiplied by 24. So I'm going to have 4 times 4, which will give me 16. And I will write 6, carry 1. So are you getting the point now? So for every number that you take the square, if 4 is the last digit, then the last digit of that square will definitely be 6. For instance, again, if I have 104 squared, this will be 104 multiplied by 104. And when you do this multiplication, 4 times 4 will always give you 16, and you will carry 1. So the 6 will always be the last digit of any number that you're taking the square, and the last digit of the number in itself is 4. Okay, so that's what I am doing here now. So the next one is 5. If I take the square of 5, I will get 25, and so the last digit is 5. Let's go up. Okay, so what about 6? The square of 6 is 36, so 6 is the last digit. What about 7? 49, 9 is the last digit. What about 8? 64, 4 is the last digit. What about 9? The square of 9 is 81, 1 is the last digit. And finally, okay, the 10 is 2 digits, and the last digit is 0, so let's leave that. Okay, so you can see that from this list now, for any square you will take, the last digits possible that you will see are 0, 1, 4 repeated 2 times. So I've taken this, I've taken this, I've taken this and this. And then the next one is 5. 5 will be a last digit. The next one is 6. 6 will also be a last digit. Then we don't have 8. The next is, I think I've taken 6. This is a repetition. Okay, so the next one, which is the last, is 9. Okay, so these are the possible last digits you are going to be getting for every square of any number at all. If you pick any number at all and you take the square of it, the last digit will either be 0, 1, 4, 5, 6, or 9. So you can pick different examples and check if this is true. For instance, let's look at this. Okay, let me just pick any number at all. Let's say 569. This is a number. If you take the square of this is going to be 569 multiplied by 569. So of course, when your 9 multiply 9, you are going to get 81, and so you have 1 carry 8. All right, so and this one will eventually be the last digit of this product. Okay, so that is to say, and you can see that it's under here. So whatever number you pick, the last, if you take the square of that number, the last digit will be any of these 6 digits. And that is what will help you answer this question. So whenever we have a perfect square, that means the last digit of that number will either be 0, 1, 4, 5, 6, and 9. Okay, that's from here now. Okay, so from here now, 0, 1, 4, 5, 6, and 9. And that will help you answer this question. So from all that we have said now, you can see that this is the perfect square here. 2 is not amongst the last digits, 8 is not among, and then 7 is not among. And that's actually what they expect you to use in answering this question. So the perfect square that we have here is 328,476. And of course, if you take the square root of that, you will see that you get a perfect number. Let's see. All right, so notice that if you run a check for this particular question now, like I said, we can check. You will see that the option A is actually not a perfect square. And that automatically brings me to a remark which I'm going to make immediately after this correction. And the correction is that please note that this 8 here is 9 and not 8. If you take the square root of this, of course, you are going to get 574 as your answer. So that's a perfect way. I think that was an error. And so that makes me to, bring this remark. And what is it? That if you have any number and the last digit is any of these 6, that doesn't necessarily mean that that number is a perfect square. So, but what we are saying is that if a number must be a perfect square at all, then it must have one of these 6 digits as its last digit. For instance, if you look at the 24 that we considered when we started, 24 is not a perfect square, even though that 4, which is the last digit, is one of these 6 digits. So, but that does not necessarily mean that 24 is a perfect square. However, if any number is a perfect square, then we are sure that the last digit must be any of these digits. Of course, you can see from the normal digits that we have, or the normal square, perfect squares that we have, like 1, the next one is 4, then you have 9, you have 16, 1, 2, 1. So you can see all of this. If you keep going further, you have 1, 4, 4, you have 1, 6, 9. All of these are perfect squares, and all their last digits are all members of these particular 6 digits that we have. And that's exactly what this examiner is expecting from you, because trying to change all of this using the prime factor approach is going to take a lot of time, and that would not allow you meet up if you must do well in this exam. All right, and so that is what we have for you in this video. Please kindly subscribe to our YouTube channel, do like, and leave your comments, and we'll always respond to your comments. Also share our videos and channels to your friends and colleagues. We will see you in our next video. Bye.